This here is one of the more strange question types on the SAT. And on the previous version of the SAT, before the digital SAT came about, this would be a question that would show up about once on each test. And what it is, we call it splitting an equation into two functions. And there's a little sort of background story to this. First of all, you need to be reminded that when you have an intersection, for intersections, you want to get both equations in the y equals format and set them equal to one another. So if I had two functions, let's just say that look like this, y equals 3x squared, and the other one is 4x plus y equals 9. Just making this up as an example. If you were given both of these and asked for the solution, first of all, you need to realize that the solution for multiple equations is an intersection. The solution for multiple equations is an intersection. So therefore, if we're finding the intersection, we would get them both in the y equals format. So this one needs to be moved around a little bit. And then we need to set them equal. 3x squared equals negative 4x plus 9. And the x value you get when you do that is going to be the x value of where the two functions intersect. So to make two functions intersect, we get them in the y equals format and we set them equal. So now, by that token, the opposite is true. If we see two things set equal, we at least have the option to imagine that these are two separate functions, and what we're looking at is the intersection of those two functions already being played out here for us. So this we can imagine is an intersection. And now in that vein, the idea that there's no solution kind of makes more sense because they're telling us we have two functions and these functions never hit each other. Now, what kinds of functions are they? They're lines. We know they're lines because lines will have x and also y to the first power. So these are two lines, and if we separate them out like this, y equals this thing, and y equals this thing, they're looking a little more like lines. And we can distribute the two. And now we have two lines in y equals mx plus b format. And we can see the m's and the b's. In other words, we can see the slopes and the y-intercepts. So what we need to know now is that when we have two lines, there are three ways this can play out. There can be one solution. The lines can hit one time, and that would happen if the slopes were different. There can be no solutions. They can be parallel. In other words, they'll never hit each other. That would happen if the slopes are the same and the y-intercepts are different. And there are infinite solutions. That means they're the same line, so they're always hitting. They're hitting an infinite number of times, and that would happen if the slopes and the y-intercepts are the same. So now that we've split this into two functions and we're interpreting this as where do these two functions intersect? And the answer to that is never. That means we're using this situation and we're seeing that it means the slopes have to be the same. What are our two slopes right now? One of them is 2k, because that's in the m spot, and the other one is negative 28 over 15. That's in the m spot. So the slopes have to be equal. So that would mean that the 2k has to be equal to the negative 28 over 15. And now we can just go ahead and solve that out. We can divide by 2 here. Now, by the way, dividing by 2 is the same as multiplying by 1/2. Just to illustrate that, if I had x divided by 2, that's the same as x divided by 2 over 1, because any number is itself over 1, and that's the same as x times 1 over 2. So I just demonstrated that dividing by 2 is the same as multiplying by 1 over 2. On the left-hand side, the 2's cancel. On the right-hand side, we can cross-simplify. 28 and 2 become 14 and 1, or let's not forget the minus sign, negative 14 and 1. And so now what we have left is negative 14 on the top and 15 on the bottom, and that's our answer.